All right, for 3.2, we're going to talk about truth tables. We're going to learn the truth tables for those 5 connectives that we did in 3.1. You know, negation, conjunction, disjunction, conditional, and biconditional. Those were so much fun. And then we're going to compute truth tables for compound statements, and we'll determine when statements are logically equivalent, and then we're going to use those De Morgan's laws. Okay, so next slide. All right. When you're doing a truth table, you're trying to figure out if a pair of similar statements mean the same thing. And so here's an example of one of them. You might be asked to find... Okay, come on, marker, work for me. There we go. You're going to be asked... Oh, Lordy B. Let me try this again. Just this one. Oh my God. Okay, I'm not using the highlighter because it just doesn't want to work. So let's just underline things. This one is similar to this one. We want to know, do they mean the same thing? And we're going to use these truth tables to figure it out. Okay, moving on. We're going to start with the most simplest truth table, and it's the one for negation. And so the first column here, which says P, this is what you're going to be negating. And you can have a statement P, and P can be one of two things. It can be true or it can be false, because you only have one statement. So when you negate that, your true statement becomes false and your false statement becomes true. And then they put this, up here, the negation of P. Man, I wish I could use my highlighter. Okay. And that's a truth table for negation, which was our very first connective. That's it. So in further truth tables, if you have a column that says the negation of P or the negation of Q or the negation of R, and we're only going to do ones that have 3 statements, nothing more, you would simply go down the list and change every T to an F and every F to a T. Yes, it is just that simple on negation. Okay, so now we come to the conjunctions. All right, so conjunctions was next, and this is a little bit too thick. There we go. All right, so now we're going to do conjunctions. And remember, a conjunction is the same thing as an and the symbol looks like that. It looked like the letter A that was missing the bar across. And you can see that it's, that's the symbol they're showing right there. Okay, now, if you're doing a conjunction, you're connecting 2 statements. And they're showing the 2 statements right here. You've got the first statement, which is P, and the second statement, which is Q. Now, there's actually going to be 4 lines to this, or I guess you could say 4 rows, because you can have either both of your statements are both true, or both of your statements are both false, or the first one can be true and the second one can be false, or the first one can be false and the second one can be true. And whenever they make these tables, they'll always go true, 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 false, false, true, false, false. They will always do that. Even in my math lab, they'll do that. It'll be a drop-down box. It'll show it that way. All right. Now, when you look over at the results, these are your results for calculating an and, because you're looking at these two. And if the first statement is true and the second statement is true, the result of the conjunction will also be true. But if you look at the rest of them, they're always falses. That's because when you're considering an and, it has to be this and it has to be that. It has to satisfy both in order for the whole statement to be true. Just like, I don't know, for education, I'm trying to think of something like, maybe there's a class out there that says, in order to register for this class, you have to have taken this prerequisite and gotten a grade of C or better. So maybe you took a prerequisite and passed it, but you didn't get a C or better. Sorry, it has to be both of those. It has to be this and it has to be that in order for you to take the next level of a class. So even though you took the class and, passed it with a D, because you didn't get the C part, oopsie, that's not going to happen. Another example, let's say you're planning your child's birthday party and you tell them, okay, you can invite anybody from your class, but they have to be a girl. Maybe it's your daughter. And you're just like, okay, we can't invite all 35 kids from your class, but let's say you invite anybody from your class, but they also have to be a girl. All right, so again, they have to be from the class and have to be from a girl. Have to be a girl. They're all from girls, sorry. I don't know. It's Sunday. I'm not quite awake. Anyway, it has to be both. It has to be this and it has to be that in order for the result to be true. Otherwise, they're all going to be falses. So if you see one F on a conjunction, just know that the result will be an F. Okay, and I'm going to stop there because I've done negation and conjunction, and I'll pick up disjunction next.